The rules of exponents. A lot of these rules can be done long way by rewriting exponents as repeated multiplication or division. However, these are here to simplify things and expedite calculations. So the first rule of exponents is the product rule. Base is the number that is raised to the exponent. So if we have same base times itself and it has different exponents, you can just write this base once and add the exponents. So let's do some examples. Let's simplify x to the second times x to the third. Now you can't do it this way. X times x to the right, x to the second times x to the right, x to the third, and then you can count how many x's there are, which is 5 in total. However, you can skip this step, especially if you have large exponents. You want to skip this step by taking the base and just adding exponents, and we get x to the 5, and this is our answer. So here's another one. We have y here times 1, 2, 3, 4, 5 y's out of here, and all together we have 6 factors of y. Now the faster way is, if you don't see an exponent, that's a first power. That's the identity exponent. You can take a variable or a number. You can always multiply it by 1 without changing the value, divide it by 1, or raise it to the first power. Those are the identities. So the faster way of doing this would be to take the base and add the exponent, and we get y to the 6th, which is our answer. Let's simplify a to the 7 times a to the 5. So we keep the base and we add the exponent. So we have a to the 7 plus 5, 12, and this is our answer. Here we have mixed numbers and variables, and this is all multiplication. And in multiplication, you can rewrite factors without changing the value, just like 2 times 3 times 5 is the same as 5 times 2 times 3, or 3 times 2 times 5, because this will give us 6 times 5, and this is 10 times 3. So we get 30 equals to 30. So I'm going to use the same property for this problem. Now I'm going to rewrite numbers next to each other. So we have 3 times 4, and then I'm going to rewrite variables next to each other. So we have x to the 5th times x to the 6th, and now I'm just going to simplify numbers and variables separately. So we have 3 times 4, 12, and x becomes to the power of 5 plus 6. So we have 12x to the 11th, and this is our answer. Here we have negative 3x times negative 2x to the 5th. So once again, I'm going to rewrite the factors. Especially if you have negatives, make sure you have them in parentheses. So we have negative 3 times negative 2. Then we have x from there times x to the 5th from over there. So now we have negative times negative, positive 6, x to the 1 plus 5. So we have 6x to the 6th as our answer. Here we have 4y to the 2nd times negative 2y to the 13th. Once again, I'm going to put numbers in parentheses. And we have 4 times negative 2. We have y to the 2nd from here and y to the 13th from over there. Now we have 4 times negative 2, negative 8. Y to the 2 plus 13. So we have negative 8 y to the 15 as our solution. Let's simplify this thing. Even though this looks crazy, if you do it one step at a time, it's not going to be terrible. The first thing is to simplify signs. This whole thing is positive, this thing is negative, this thing is positive, so positive times negative, negative times positive, the whole answer will be negative. And now we don't have to worry about this negative quarter. Now let's rewrite all the numbers next to each other. So we have 2 times 1 out of 4 times 6. Now remember, whole numbers are out of 1. Now I'm going to write all the x variables next to each other. So we have x to the second times x to the third times x to the third again. Then we have y. Then we have another y. And then we have y to the seventh. So this whole thing becomes 2 times 1 times 6. We have negative 12 out of 4 times x to the 2 plus 3 times 1 y to the 1 plus 7. So the whole thing is still negative. 4 goes into 12 3 times. X to the 2 plus 3, 5 plus 3, 8. Y to the 1 plus 1, 2 plus 7, 9. And this is our solution. That's all.